you'll recall, in the previous class we were starting section 5.1, which deals with consumer and producer surplus. We're going to continue that idea, first reviewing a bit and then moving forward, and we will finish off this movie dealing with price ceilings, price floors, and deadweight loss. But first, let's go back and briefly look at what we discussed in the previous class. We were talking about the idea of having a situation where you have a graph with some quantity and some price, and you're going to be given two functions. One of them is going to be a supply function, and that supply function we will call S of Q, and the second thing called a demand function, which we'll call D of Q. Now, in most cases, or a lot of cases, you will see the variable Q used to represent the quantity of units that are in play or in consideration. Sometimes you'll also see these functions with the variable X involved. Don't let the variable confuse you. Okay. The supply function is the amount of product that the supplier is willing to provide, and S of Q as well as D of Q represent the selling price. So what's going to happen is, with either function, you're going to substitute in a value for the number of units available, and then when you evaluate that function at that number of units, it will indicate a selling price. In the case that we're going to look at here as an example, we're going to use 3 plus Q squared as our supply function, and we're going to use 35 minus Q squared as our demand function. Remember, the demand is the number of units and the price at which people will pay to get those units. The two values that your two functions that you're given here are just two used as an example. In the real world, there are techniques for deriving these equations, but that's beyond the scope of this particular class. If we graph our supply function, first notice it's going to be a parabola because it's Q squared, and it's going to intersect the y-axis at 3. Because the Q squared is positive, it's going to open upward, and we're going to have a supply function S of Q, something like that. The demand function, notice, has a negative Q squared, so it's going to be a parabola. It's going to open downward, and it's going to intersect the vertical axis at 35. So the other parabola is going to do something like this. I realize it's not the best graph, but it gives us something to work with. There is a point at which the functions intersect. This is called the equilibrium point. The idea of the equilibrium point is this is a price and number of units that both the supplier and the consumers are willing to meet at, if you would. It's a negotiated thing. The negotiation doesn't take place with people sitting down around the table so much as it does with, in the marketplace, seeing how many units are being purchased at a particular price and then determining what price is satisfactory for both based on the consumption at a particular price. In this case, we have an equilibrium point with a value down here we'll call Q star. Q star is the number of units being sold at that equilibrium price. P star is the price at which these units are being sold. Now, something to notice is if you look at the dotted lines from Q star and P star, it forms a rectangle. The area of this rectangle is actually very straightforward to compute. The area of this rectangle is going to be P star times Q star, or if you want, Q star times P star, either way. But if you think about this for a minute, you'll quickly realize that this shaded blue box represents the total revenue. Okay, so we have some information here. We have that the revenue is going to be equal to P star times Q star. And the revenue geometrically is represented by this blue box. Okay? That's going to come into play in a variety of places for us, so we'll keep that in mind. Okay, when we have a problem like this where we're looking at either consumer or producer surplus, there are several features that we want to notice. First, let's do it in this. Okay. We have this area up here. This area up here represents a distance between the actual price at which the unit is being sold for and a price, a higher price, that some consumer would have been willing to pay. When you go into a store and you find a product and it's either on sale or priced lower than what you anticipated it being, paying this lower price allows you to save some money. Okay. And paying that lower price allows you to receive what is called a consumer surplus. You have a surplus of money when you leave the store. It's money you would have been willing to spend but didn't have to spend because of the price of the unit. Okay. So what winds up happening is this whole top area here is what is called consumer surplus. This light green or the shaded green area represents consumer surplus. It's money that you would have been willing to spend but didn't have to spend. Now, as people come into the store, some would be willing to spend an extra $5, some an extra $10, some an extra $1. But what you do is you look at the amount of money they would have been willing to spend minus what they actually spent, and for that one person, that is how much consumer surplus that person realized. When you add this up over all of the people who go into the store and find the product at a lesser price, that lesser price allows them all cumulatively or together to save some amount of money, and that amount of money that is saved is the green shaded area. Okay? So the consumer surplus is our CS. On the other side, you do have a situation where the producer could have sold the product at a lower price. If you take a look down along here, these are all lower prices that the producer could have sold the product at. But instead, they sold it at this higher price there. So for each product they sell at this higher price, they receive more money than what they would have by selling it at a lower price. By selling it at this higher price, you wind up with what is called a producer surplus. And we'll abbreviate that as PS. So this section here, this yellow shaded section, is going to be the producer surplus. We can very readily get an equation for either the consumer surplus or the producer surplus by looking at the geometry of the situation. In the first case, let's say consumer surplus. What you want to do is you want to include all of the area underneath the consumer line, and you want all of that area underneath the consumer line minus the revenue, because the revenue is what they leave at the store. So what's going to wind up happening is, to get all of that area underneath the demand curve, what we're going to wind up doing is we're going to integrate from 0 to Q star. Q star gets us over to the equilibrium point, and we're going to integrate our demand function with respect to Q, and then from that we're going to subtract the revenue, P star, Q star. And if you take that entire area underneath the demand curve, subtract off the revenue, what you're left with is the green shaded area. We can use a similar line of reasoning to evaluate evaluate and create a function for producer surplus. In this case, we don't want an area below the curve, the blue curve, okay, the supply curve, but we want the area between the equilibrium point and the curve. In order to accomplish this, what we're going to do is we're going to compute what was originally that whole blue shaded box, the revenue, which is our P star, Q star. And then we're going to take away the blue shaded area underneath, which is the producer, which is the supply. Okay. So what we're going to do here is we're going to then subtract from 0 to Q star our supply function, dq. You will be responsible for knowing how to generate these based on the graph and an explanation. What I will do on a quiz or a test is I will give you either the supply or the consumer surplus equation, and I will ask you to derive it, to explain where it came from based on the graph and based on a brief written explanation. Be sure that you can derive these. Okay. That oftentimes happens on a quiz, like this Friday's quiz. It may happen on test 3, and it is also a possibility to happen on the final exam. Okay, with that said, let's do an actual example where we're going to compute the producer surplus, the consumer surplus, using the demand function that we referenced above, the demand function being 35 minus q squared, the supply function being 3 plus q squared. Recall first off, if we're going to do either of them, the first step is to compute the equilibrium point. Friday in class, we discussed two techniques for computing the equilibrium point. One technique is to place one of these functions in y1 on your calculator, place the other one in y2 on your calculator, graph the two functions, and then here, to compute the point of intersection on your calculator, you go to Calculate, and then you choose option 5, which is Intersection. Do not use trace. Trace is not accurate. It just gives an estimate. It does not give you an exact point. You need an exact point. So one way to do this is to go ahead and just graph them, locate the point of intersection. On your calculator, you calculate, option 5, intersect, and boom, it's done. In some cases, that is definitely the easier and quicker way to go. If you have two equations like this, what you may also want to do is to realize that this equilibrium point occurs where these two functions are equal. So you can just take the two functions, set them equal to each other. Okay. So this is going to give us 2 times q squared equals, and if I subtract 3 from each side, that's going to give us 32. Dividing by 2, we have 16 equals q squared, or q is going to be plus or minus 4. Keeping in mind that negative doesn't make sense in this situation because that would be a negative number of units, we're going to use the positive 4. Okay. So from this information then, this gives us a q star is equal to 4. From that, we need to compute P star. To get P star, you want to substitute the value of Q, 4, into either of the two equations. Remember, because the equations are intersecting, they're sharing a common point, the x value and the y value, or in this case the q value and the p value, will be equal, so it doesn't matter which of the two functions you substitute q star into. Personally, I use the easier one. It's less likely to make a mistake. Speaking of not making a mistake, we get that the selling price is going to be 19. The number of units sold is going to be 4. This information here can then be used to compute the revenue, which is going to be 19 times 4, and 19 times 4 is 76. Now, we don't know if this number of units Q is in terms of single units, if it's in terms of crates, if it's in terms of an entire semi-load. Okay, we aren't given units, so we're not going to try to work this too far, but the revenue is 76, whatever it is, $76, $76 million, whatever. From there we can go on and we can first compute the consumer surplus. Recall that the equation for consumer surplus is going to be this integral from 0 to Q squared, whatever our demand function is, integrated with respect to D, minus P star Q star. But we know that this P star Q star has a value of 76. So what this works out to be is the integral from 0 to 4. We know Q star because we figured it out earlier. Our demand function is going to be 35 minus Q star dQ minus 76. On these particular problems, you can work them out either by hand, or if you want, you can work them out on the calculator using the Math 9 option. I would put in the 35 minus the x squared, comma, going to run from 0, comma, 4. Oops, need to put in an x first. We're going to integrate with respect to x, comma, 0, comma, 4. And when you integrate this, this integral works out to have a value of 118.667, and we're going to subtract the 76 from it, which is going to give you 42.667 as the consumer surplus. Now, as we discussed with revenue, we don't know what the units on this value are. We don't know if it's in terms of dollars, in terms of thousands of dollars, but for this particular situation, it's just 42.667. Third thing we're going to do is to compute the producer surplus. With the producer surplus, we're going to use the equation P star Q star minus the integral from 0 to Q star of our supply equation dQ. So for this particular problem, it's going to be the 76 minus the integral from 0 to 4. The supply function here is 3 plus Q squared dQ. As with the previous problem, you can either work this out by hand, or if you just write down on your paper this integral, okay, if you write this down, I know that you're going to go to your calculator to get your final value, and I would expect you then to just once again do the Math 9, plug in 3 plus the x squared, comma, x, comma, 0, comma, 4, have it integrate, and you wind up with 33.333. And when you subtract 76 minus this value, you wind up with 39.667, let's say. 39, no, that's not right. 42. Sorry about that. Should have done it on the calculator. Okay, so for this particular problem, you have 3 pieces of information. One, you have the revenue generated at this particular selling price. have the amount of money that the consumer is going to save by the units selling for $19 each. Remember, P star is 19. Let's just assume this is dollars. So each person comes in, they pay $19. By the time Q units are sold, altogether everybody will have saved this much money. In the end, by having sold them at this price of 19, whatever the units are, the producers will have gained an extra this much money. Okay, just want to make sure that's right. Okay, yeah, it's kind of interesting if they both worked out to be the same value. Okay, so there's what's going on with that. So you have 3 things to walk away with, actually 4 or 5 things. One of them is the total revenue generated. Second, number of units sold. Third, the price at which they're going to sell at. Next is your consumer surplus, money that the consumers have saved, they didn't have to spend. Lastly, producer surplus. This is additional money that the producer makes by selling it at a higher price than what they could have. It was kind of interesting the other day. Was at a auto dealership, and they had a special 50th anniversary car there, a muscle car, and they had the list price, the window tag with all the stuff on it, and then they had an addendum to that where they had the original price of the car, which was $56,000. Then on this addendum tag it lists additional dealer profit $5,000, taking the price of the car to $61,000. Do folks actually sell things for more than what they could? Well, that's clearly a case where they did. Why could they sell it at that? Because it was a special 50th anniversary edition. It's a very limited car, and they figured they'll just wait till somebody comes in who really wants it. Same thing happens here to produce producer surplus. Okay, selling at a price higher than what it could have been sold at. Okay, at this point we're going to turn our attention to the information that starts at the bottom of page 3 in the notes. The top of page 3 we had already pretty well worked through in class, and it's just an example similar to the one that we just now did, the only difference being different equations being used for supply and demand functions. Oftentimes you will see scenarios where the government may intervene in pricing, either to keep things higher or lower than that they would naturally go to. One such example of what are called artificially low prices is rent control. Okay, New York City has rent control. The idea is in the various burgs throughout the city, the government determines the maximum price that a landlord can charge per square foot for an apartment. Apartments can get quite pricey. My sister and her husband used to live in Manhattan, and at that point in time they were paying $2,000 per car to park their cars at their apartment. So they were paying $4,000 a month just to park the cars. I didn't ask them how much the rent on the apartment itself was, because I'm sure it would have been quite scary. Okay, but they were paying a huge amount of money just to park their cars at the apartment, which would really prohibit middle-class individuals from even having hopes of living in an apartment building like that. Well, in the various burgs of New York City, because of demand being so high for housing, the prices there could also be driven to the point where people like teachers, firefighters, policemen, important jobs that serve the community wouldn't even be able to afford to live anywhere near where they work. So the government intervenes and requires that prices be set lower than the equilibrium price, or the price that the market would actually allow it to be. To draw a picture of what's going on for artificially low prices, let's say we have a situation like this, where where we have a demand function. These functions don't always have to be straight lines. We have a supply function. Now in this case, the supply would be the landlord. The demand would be the renter. If things were allowed to run and just settle in where they would, we would have an equilibrium price like this. This would be Q star. This would be the number of apartments available. And P star would be the price to rent one of those apartments. Well, what winds up happening in this situation is the government steps in and says you cannot set the price any higher than some given amount. That amount typically being a price per square foot. Okay, so what happens here is that the price is set lower. Okay, so let's say that our low price, now another name for this is a price ceiling. Okay, so they place a ceiling on how high the price can go. You can rent it for less, you just can't rent it for more. So they create what's called a ceiling price, we'll call it P sub C, and where things wind up settling in now is we have this being the number of apartments that landlords are willing to provide at this price. Now, in setting things artificially low, a couple things happen. First off, the producer loses some money. Okay, originally the producer was making this much money as well as this much in surplus. The producer does not realize all of that surplus. What the producer or landlord now realizes in surplus is this much money. You can see that it's a significant reduction in the amount of money that the landlords receive. On the flip side of that, you have the consumers who before were getting this as their surplus. They do lose this section. Okay, so they lose that section, but in exchange for losing that section, and we'll get rid of a couple of those highlights over there, they pick up this area here, which was originally part of the producer surplus. And the hope is that the amount in this shaded area that was originally part of the producer surplus, you want this amount of area here to exceed this amount that they've lost. Now, why have they lost some? Well, the reason they've lost some is the producers, the landlords, at this higher price are willing to provide this many apartments. When the price is set lower, okay, it's not attractive for them to provide as many apartments because they're not making as much profit. And now you have some new lower number of units available. But the objective is to help the consumer by setting the price lower than what it could have been. Okay? And by setting it lower, you're hoping that they will pick up some additional surplus here. Okay? It'll make it more attractive for them to live in that area. In fact, in a lot of the burgs, I believe the police and the fire, and I'm not sure about the teachers, they're required to live in the community where they serve. So if the government did not intervene, there wouldn't be a place that they could even afford to live. Okay, so there's what's going on with price ceilings. With a price ceiling, it benefits the consumer. Results in less units available. It reduces some people say, well, that's good, they don't deserve all that money anyway. But one of the things to keep in mind, if it becomes unprofitable, they find some other business, and if everybody found some other business in housing, there'd be a whole lot of people living in the street. So you don't want to set things so low that the supplier is forced out of business, okay? Because they do provide a service that people need. If they didn't provide a service that people need, nobody'd buy it, and they'd go out of business anyway. Okay, so a price ceiling is when a price is set artificially low. At this artificially low price, a new level of supply results, and it reorients everything. A second scenario is if prices are set artificially high. This happens at times as well, where the government will intervene and establish what is called a price floor. It sets a minimum price at which something can sell. Okay. This happens, well, one case I can think of is with milk prices. If the milk prices go too low, the farmers can no longer afford to produce milk, and I really don't think the country wants to be faced with a situation where there is no milk. Because not only does that take away milk, but it takes away cheese. Oops, there goes your pizza. It takes away ice cream. It takes away cheesecake. It takes away all kinds of products that are milk-based. So the government wants to ensure that the farmers make enough money to stay in business and it remains profitable for them. In this case, you have the number of units Q. You have your price. Let's see, what colors did I use up here? Try and maintain some consistency. Okay. Here's the demand. The demand in this case is going to be folks like us who will buy milk-based products, and here's the supply. As before, you normally have this equilibrium point where you then get an equilibrium quantity and an equilibrium price. The government will intervene and they will establish a higher price like this, and what winds up being the case now is the consumers only benefit this amount, whereas before they got all of that plus they got all of this. Okay. By setting the price high, the consumers lose out on that amount that was just removed. Originally, the farmers would have received all of this amount. This would have been the producer surplus. Okay. All of that was the original producer surplus, but by setting the price high, they miss out on this. In exchange for missing out on that, they gain all of this. And they still retain this portion here. So I think you can see that this does benefit the farmers by setting the price artificially high and keeping them in business. Okay, we have friends who have a dairy farm and it's close. It's not like they're making a killing or anything like that. That's nowhere near the case. So setting the price artificially high is actually what keeps them in business, because there are periods of time when the price is not protected and it drops down. They're losing this is what is lost on both sides of the ledger when the price is set artificially high. This amount, total amount that is lost, is called dead weight loss. Okay, so for this particular graph, that's money that is lost either to the producer or to the consumer. So that's money that's taken off the table. Neither side gets that. And the hope is that the dead weight loss will be less than the benefit to one side or the other. In the previous graph, you can see here where the dead weight loss would have been. The dead weight loss would have been this. And one of the things that has to be very carefully considered is if the dead weight loss is greater than the benefit to either the producer or the consumer, establishing a price floor or a price ceiling is actually going to hurt things. It's not going to improve the situation for either side. There is on page 476 in your text a chart that discusses the benefits and drawbacks to dead weight loss. It will elaborate further. Let's try dead weight loss. It will elaborate further for you on who benefits and who loses in either the case of a price ceiling, artificially low prices, or a price floor, artificially high prices. Okay, so what we've taken a look at here is how to compute consumer surplus, how to compute producer surplus, how to compute equilibrium price, as well as the equilibrium quantity. We've also looked at the effects of setting prices artificially low or establishing an artificially high price, and in either of those two situations, considering what the dead weight loss is going to look like. I then pointed out to you at the very last a chart that summarizes very nicely for you the benefits and drawbacks to dead weight loss, whether you have a floor or a ceiling in your price. Okay, at this point you should be ready to take a run at the homework for section 5.1. I wish you the very best, and I'll have a movie posted for you for Wednesday.